Welcome to limits. All right, so here's what a standard limit type question in calculus will look like. So the limit of x when x is approaching 2 of the function x squared minus 4 divided by x minus 2. So the problem with the original function is when x is equal to 2, you've got a 0 in the denominator. And so that gives us an undefined situation. So the solution is you can find the limit by looking at the function as it approaches x equals 2 from either side of the graph. So one way to do this is to build a table and plot out the x's and solve for the function as x approaches the limit, which is 2 in this case. When x is equal to 1.9 in the function, we get a result of 3.9. And with 1.99, we get the result of 3.99. In 1.999, we see 3.999. And we're starting to see a trend here. And then if we go ahead and do it at 2.0, we see our undefined. And let's just go ahead and finish out the graph. And we can see that going from both sides, 2.1 to 2 and 1.9 to 2, it appears that the limit is approaching 4. We've got our limit as 4, and if we graph the function in Desmos, we can see that it's a straight line. Now, if you click on the line in Desmos and you click and hold, you can scroll up with your mouse up to where x is equal to 2. And even in Desmos, it shows at that point a broken line, a circle, because it's saying that at x equals 2, the equation is undefined, y is undefined. But when we look across, the line is, if we look at the line as a continuous line and we look across, we can see that the limit or y is at 4. So now what happens when we ask a question like this, where we give you the limit and x is approaching infinite? One way to deal with this is to just divide everything in the equation by x. And then once we've got that, we can set x equal to infinite. And with infinite over infinite, we can call that 1. And anything that's, whenever we've got infinite in the denominator, we can call that 0. So you can see where the second part of the equation, after we've derived the original equation, dividing everything by x, the second equation, we put the infinites in. And we can see that 3 infinite divided by infinite, we can just call that 1, so that 3 drops down. And then the next one in the numerator is 2 divided by infinite or infinity. And so you know that that's that part of that equation, the 2 is becoming infinitely small. So we can just put 0 in there. Basically anything divided by infinity is going to be infinitely small, approaching 0. And then in our denominator, we've got infinity divided by infinity, which gives us 1. So 3 plus 0 divided by 1 is 3. And if we graph that function 3x plus 2 divided by x, I changed the x scale here and set it to like 500. You can see initially, right, anything basically less than 25, you can see that curve coming down where x is close to 0 and approaching like maybe 25, 50. You can see that the curve is coming down and it appears to be settling on 3. And I've graphed the point, or I've set the point way out here at x equals 400. the y in the equation is equal to 3.005. So you can see it looks like it is, in fact, approaching 3 as we get bigger and bigger on the x.